Imagine two people eating the same meal at the same time with exactly the same number of calories. At first glance, there is no difference between them. Nothing that suggests their bodies will react completely differently in the next few minutes. The only difference lies in a seemingly insignificant habit. One of these people goes for a walk 10 minutes before eating. The other leaves the table 10 minutes after eating for a short walk. No exertion, no exercise, just calm walking. But this is exactly where something begins that most people never notice, because what happens inside the body afterward is not a small effect, not a nuance. It is a completely different biological process that determines how the body handles energy. Blood sugar rises in different ways. The hormone insulin is released differently. And deep within metabolism, a decision is made that has long-term consequences. Will this energy be used or stored as fat? Most people believe walking is simply movement, something for steps, maybe for the mind. But science shows something surprising, something that hardly anyone expects. The timing of this simple walk can influence metabolism more strongly than many factors discussed every day. Sometimes it is not what we do, but when we do it. After almost every meal, the same thing happens to many people. The body feels heavy, concentration drops, a quiet urge to sit down or even sleep becomes noticeable. This feeling is often ignored, seen as something normal, inevitable. But biologically, it is anything but harmless, because precisely in the minutes after eating, one of the most sensitive phases of our metabolism begins, a phase in which the body decides how it will handle the energy it has taken in. Worldwide, millions of people suffer from elevated blood sugar, insulin resistance, or visceral belly fat. And surprisingly often, the cause is not the food itself, but what happens afterward, or does not happen. Hardly anyone is told that the human body is extremely sensitive to movement around meals, not to intense training, not to discipline or willpower, but to simple, natural movement. A slow walk can send the body a clear signal, a signal that influences hormones, guides blood sugar, and even determines whether energy is burned or stored. But here lies the crucial point. The body does not react the same way when this movement happens before eating or after. In both cases, something good happens, but they are two completely different processes. To understand this, one must look deeper, into the muscles, into the hormones, and into the way the human body has learned over millions of years to deal with food and movement. When a person goes for a walk before eating, the body enters a special state of preparation. No food is yet in the system. Blood sugar is relatively stable. Insulin is at a low level. And precisely in this calm state, a subtle but crucial change begins. After just a few minutes of movement, the muscles awaken. They need energy, even if the walk is slow and relaxed. To provide this energy, muscle cells open special channels on their surface, transport pathways that can absorb glucose without relying on insulin. For the body, this is like a quiet signal, a kind of early warning. Energy will soon be needed. Systems should be ready. This preparation changes how the body responds to the upcoming meal. When food arrives later, glucose from the meal enters a system that is already organized. The muscles are ready to absorb it. Blood sugar rises more slowly, and the pancreas has to release significantly less insulin to accomplish the same task. This effect is described in science as improved insulin sensitivity. That means the body reacts more efficiently. It needs less hormonal pressure to deliver energy where it is needed. From an evolutionary perspective, this behavior is no coincidence. For most of human history, people moved before consuming food. Hunting, gathering, walking. Only then did they eat. Metabolism is still adapted to this pattern. A walk before eating mimics exactly this ancient signal. It tells the body, movement comes first, food follows. And this sequence changes the entire metabolic response. But this is only one side of the story, because when movement happens after eating, the body reacts in a completely different way. When the walk begins after eating, the body is already in a completely different state. Food has been consumed. Glucose enters the bloodstream. Blood sugar levels rise, and the pancreas begins releasing insulin. At this moment, Insulin takes on the role of a traffic controller. It tries to move excess glucose from the blood into the cells. But without movement, the path is limited. Some of the energy remains in the bloodstream longer and is eventually stored as fat. When a walk begins, this dynamic changes immediately. Working muscles need energy. They open their uptake pathways and begin pulling glucose directly from the blood, independent of insulin. For the body, this is a relief. Blood sugar drops faster. The amount of insulin required is reduced, and dangerous post-meal spikes are flattened. Studies show that just 10 to 15 minutes of slow walking after a meal can significantly reduce the blood sugar response. This effect is measurable especially in people with insulin resistance or prediabetes. Walking after eating acts like a correction. It intervenes when metabolism is under pressure and helps the body distribute the absorbed energy sensibly, instead of storing it long term. Many people notice this effect intuitively. They feel more alert, clearer, less heavy after a short walk. What they are feeling is not imagination. It is the result of more stable blood sugar and a calmer hormonal signal. But here lies the crucial point. Although walking before and after eating looks similar, both variants fulfill different biological tasks. At first glance, the difference seems small. A walk is still a walk, but inside the body, two completely different programs are running, depending on when the movement takes place. Walking before eating acts like preparation. It tunes metabolism, makes muscles ready to absorb energy, and ensures that incoming energy is processed efficiently. Blood sugar rises more slowly, and the body needs less insulin to control it. Walking after eating, on the other hand, intervenes when metabolism is already under strain. It helps remove excess glucose from the bloodstream quickly, reduces dangerous spikes, and relieves the pancreas. Both variants have their place, but their effects differ depending on the goal and the individual's physical condition. For people with stable health, walking before eating can help maintain insulin sensitivity over the long term. For people with elevated blood sugar, prediabetes, or pronounced belly fat, walking after eating is often more effective because it targets the problem exactly where it arises. Interestingly, intensity plays almost no role. No fast pace is needed, no sweating, no training. The body already responds to calm, steady movement. What matters is not exertion, but the signal. Movement tells the body that energy should be used, not stored. And this exact signal is often lost in modern daily life. Sitting before eating, sitting after eating. Metabolism receives no instruction on how to handle energy. But before this insight sounds too simple, it is worth taking a closer look at the limits and risks of this habit. For many people, the idea sounds almost too simple. A short walk, and metabolism responds more favorably. But this simplicity is precisely what makes the method so powerful. Regular movement around meals can help keep blood sugar more stable, improve insulin action, and reduce the amount of energy that is stored as fat long term. Visceral belly fat, in particular, is highly sensitive to frequent blood sugar and insulin spikes. Digestion also benefits. Gentle movement supports the transport of food through the gastrointestinal tract, which many people perceive as a lighter bodily feeling after eating. At the same time, some report better concentration and less fatigue. However, not every body reacts the same way. In people prone to low blood sugar, movement around meals can trigger dizziness or weakness, especially when medications are taken that lower blood sugar. During pregnancy, with chronic illnesses, or with a history of eating disorders, this habit should only be tried with caution and medical supervision. What is helpful for one body can be a burden for another. Therefore, it is important not to view these effects as a general rule, but as an observation. The body sends signals, and they deserve attention. This information is not intended as medical advice. It is meant to help understand how human metabolism responds to simple stimuli and why small changes in daily life can have a big impact. But what does all of this mean when summarized? And what role does this walk really play in the bigger picture of health and energy? So what really happens when you walk before eating or after eating? It is not about calories, not about discipline, and not about fitness. It is about signals. A walk before eating prepares the body. It tells metabolism that energy will soon be needed, that muscles should be ready, and that insulin can work efficiently. A walk after eating intervenes when the body is already reacting. It helps remove excess glucose from the blood, relieves hormonal systems, and prevents extreme spikes. Both paths lead to the same goal, a calmer, more stable metabolism. But they reach this goal in different ways. Science is not surprising because it is complicated. It is surprising because it shows how strongly the body reacts to small, seemingly insignificant decisions. Sometimes it is not the meal that makes the difference, but what you do before or after it. Pay attention to your body. Observe how it reacts. And if there are health uncertainties, speak with a doctor before introducing new habits. And now a question for you. Do you prefer walking before eating or after? Have you noticed a difference? Write your experience in the comments, ask your questions, and subscribe to the channel if you want to learn more about how energy, fasting, and movement influence the human body.